Sciences. And for those of you who are joining us for the very first time, the National Academy of Sciences is a private, nonprofit institution that gives the government objective, evidence-based advice. LabX is the team at the National Academy that takes all that fancy science and makes it fun. They create video games, shows, board games, and video series to make it digestible. And actually, here's a very fun, full circle fact. The National Academy of Sciences was signed into existence by Abraham Lincoln in 1863. And then, almost 150 years later, LabX's sister program, the Science and Entertainment Exchange, gave scientific advice to the filmmakers behind the 2012 classic film, Abraham Lincoln Vampire Hunter. So, you know, how Abraham Lincoln had no idea that he was signing into existence the very ability to make his own film about being a vampire hunter more scientifically accurate. And on today's show, you, the audience, and our panel of comedians are going to be learning all about exosuits, next generation prosthetics, and more from our scientific expert. We're also going to find out what he is like when he is outside of the lab. So what he's like as a human, in addition to what he's like as a scientist. I want to point out that this is an interactive show. So the beauty of doing this online is that we can get all of you involved. We want to hear your jokes. We want to hear your questions. We want you to be playing these games right along with us. So if you look on your browser right below where you're watching, you should have the ability to type comments and to see polls. And we're going to use those throughout the show. So if you can't see it, you might need to exit out of full screen. Sometimes that lets you see the chat part. And I already see questions that have come in here. So already I'm getting questions like, what's the most realistic depiction of robots in film? When will we be able to live the Jetsons life and go to work to just push a button and let the robots do all the work for us? We're going to answer questions like that over the course of the show. We're going to literally answer those questions. But first, let's test out those polls. So as the comedians are guessing in the questions, so are you going to get a chance to guess. We're going to throw up a test poll right now. So click over to that and let us see your answers. The test poll is, what superpower, if you could have a superpower, would you most like to have? Would you rather have A, the ability to fly, B, invisibility, C, you can create pasta using only your mind, or D, this poll is not working for me? So let's see if the poll is working for you. If it's not a problem. You can still have fun watching the show. If you can see this, that's really all you need. If you can do the polls in the chat, that's a bonus, but don't stress either way. Also, after tonight's show, people really like this part of the show. There will be a post-show email with links to go deeper into our scientist's work, get deeper into his research, and to hear more from all of our comedian panelists. But this is the key thing. There's also a trivia question in that email. And if you get that trivia question correct, you get a prize so valuable you cannot buy it with money. Doesn't matter how much money you have, you cannot buy this prize. You have to answer the post-show email trivia question correct. And that is, you can join the immortals on the wrong answers only scroll of glory. It's an honor that is up there with the greatest honors of all mankind. And here are the folks who nailed last month's question, a trivia question about dinosaurs from our last episode. This is last month's scroll of glory. Congratulations. Congratulations to Alana, to Azul, to Brianna, to Cadence, to Cooper, to Naomi, to Grayson, to Haley, to Icarus, to Jane, to Jason, to Jill, to Katie, to Casey, to Catherine, to Kevin, to Kristen, to Ryan, to Luke, to Martha, to Mary, to Peter, to Linda, to Ruben, to Rylan, to Riley, to Stacy, to Stephanie, to Terry, and to Tina. That is an incredible group of people. I love that Icarus, one name only, was also up there. Icarus, you flew too close to the sun and you got onto the scroll of glory. Good for you. I hope you survived. We also asked in that post-show email, we asked viewers to tell us about their wildest experiences with our modern day dinosaurs, which are birds. And we got some really fascinating responses from people. I'm going to just share a few of them with you. One person said, I once saw a duck eat a chicken nugget, and I think it changed me forever. And you know what? That is deeply, deeply disturbing. So thank you so much for sharing that with us. Someone also added that they had seen, this is what they said is their weirdest experience with a modern day dinosaur, a bird. They were parked in the Catalina Harbor. My father had set ribs to defrost in the sun atop our boat. This is already the richest story that I've ever heard in my life. A seagull snatched the ribs up, but dropped them a few seconds later. My father dived a good 12 feet into the water to recover them. The ribs acquired some sea salt and ended up being some of the best ribs we've ever had. Incredible rib recipe that it involves. You have to have a yacht, you have to have a seagull drop them into the ocean, and then your wealthy father has to dive into the waves to catch them for you. But delicious, delicious ribs right there. And the last one, someone said, there was a baby bird in my yard next to a fountain that we have, and the birdie just stood there, and I fed him bread with a spoon. That is wonderful. Well, that's a whole story right there. A beautiful short story, feeding your bird bread with a spoon. Disturbing or heartwarming? You'll have to tell me what you think in the chat. Someone is also saying, if Lincoln had been a robot, would he still be president? Interesting question. Probably constitutionally never been president in the first place, but we will get into all that. Speaking of which, let's get into tonight's show. Enough of the past, let's get into the present. Today, we have an incredible panel of comedians who are going to be playing. We've got Rob Hayes, Naomi Ekperigin, and Joe Firestone. Look at this panel. Hello. Hi, everyone.
Hello.
Hey.
Thanks so much for being here. And we also have an amazing expert. And rather than me telling you all about him and how wonderful he is, let's instead hear from him in his own words about why he studies what he studies and what he does. Here is a video.
As a kid, I was very reckless. I broke a lot of bones and got a lot of stitches doing stupid things. And as I got older, I continued to injure myself through sports. I guess I was always testing the limits of the human body. And in college, I discovered biomedical engineering, which was a much safer and academic way to test the limits of the human body, and eventually got into these fields of human movement and science called biomechanics and wearable assistive technologies to help individuals with disabilities or to help those of us who are currently healthy to remain healthy and active as long as we can. How you doing? I am Karl Zelik. I am an engineering professor at Vanderbilt University, where I focus on biomechanics, prosthetics, and exoskeletons. I'm also the chief scientific officer at HeroWear, a workforce wearables company based out of Nashville.
All right, Karl, thank you so much for being on the show and letting us talk to you about your work.
Yeah, thanks a lot. This seems like a fun and quirky way to chat about science and tech. Looking forward to it.
Yes, I think fun and quirky is, your expectations are in the right place. So panelists, you're going to get a chance to talk a ton to Karl over the course of the show. But this is your first opportunity to talk to an expert in biomechanics and exosuits about what he does and the implications for all of us and for the future of our lives. So we call this segment, You Do What? And in this, you're each going to get to ask your very first question. So Joe Firestone, let's start with you. What is the first question you would like to ask Karl Zelik?
Okay, this is kind of, is it possible, do you think, in the near future, if your head, like if you get most of your head popped off, could you have a robotic neck to attach your head to your rest of your body?
So the question is, if you're completely decapitated, if we could just replace your neck and you'd keep on going?
Yeah.
I'd say it seems right. That seems like the question. Very
I don't like your
paraphrase.
chances on that one. I'd try to keep the head attached to the body as long as you can.
Okay. That's the first piece of really practical advice. We're one question in. We got really practical advice from Karl. Keep your head attached to your body. Naomi, what's your first question for Karl?
Okay. Are you working on skin tones for prosthetics so we have a range and not like a Band-Aid situation? Do you know what I mean? Where it's like only that like pinkish beige.
Yeah, definitely. That's really important. Anytime we're putting technologies on people, these are wearable technologies, whether they're prosthetic limbs or exoskeletons, they need to fit into people's lives. And part of that is how they perceive themselves and how they're perceived by others. So yeah, there are prosthetic limbs already that have different shells or cosmeses that are different skin tones. And then there are also people that really want to customize and much like you would get a tattoo, create devices that really embody who they are.
Wait, so it's called a prosthesis, but then the part that looks like it is called a cosmesis?
Yeah, they like a lot of words that end in cis.
Interesting. That's fascinating. Rob, your turn.
Yes. This is more of a concern. Like, is there a movement being made to prevent robots from identifying buses in like a gallery of pictures? Because that's really the only way I've been able to prove that I'm human is that, like, where's there a crosswalk? Where's there, a boat? So are we trying to make robots dumber so that we can sign into stuff?
I see. Yeah, that's a good point. That's not really in the realm of wearable robotics, but I agree with you. I think the artificial intelligence, machine learning realm, pretty soon we're going to have difficulty proving that we're humans and they're not.
One of my favorite things about doing these shows where comedians and scientists talk to each other is getting to hear the ways that scientists use the phrase, yeah, that's a good point. That was a really beautiful use of it. I think that's fantastic. Well, Karl, what about some of these questions from the chat, from the people who are watching? How close are we to living the Jetsons life, where we're just going to push a button and, robots are doing all of our work?
First, I think somebody dated themselves with the Jetsons reference.
Wow.
Okay. Around?
Wow, savage, Karl. Okay.
Yeah. From what I recall of the Jetsons is that was the family that lived on a kind of a space planet. And I think a lot of the technologies that they had are in the seedlings. They had flying vehicles, and some of those exist. There's at least proof of concept for some different personalized flying vehicles.
What?
They had some robotic assistants, as I recall, and that's starting to become more of a reality, with technology today.
Wait, Karl, are you young? Because you're like saying you recall the Jetsons, and I'm like, are you 15? Are you also a prodigy in robotics?
Got a few more years on me than that.
The Jetsons had moving sidewalks, and we only have those at airports. We got to get those in more places.
Yeah,
Totally agree. That's something we can all get behind for sure.
Sorry, can we just go back to the flying cars? That's like a thing now?
I don't think it's a common thing, but I've definitely seen technologies where they've shown proof of concept. You can create small personal vehicles that fly.
One last question. This is just a yes or no from the chat. We're going to get a lot more questions from the chat as we go, but one just yes or no question from the chat is, when is astronauts going to use no spacesuit? So when do you think astronauts will be using no spacesuit?
I'll go with no.
Okay, yeah. That's probably okay. Well, let's get into our, there's tons of amazing things about your research. And I want to start by kind of looking at the tools, the equipment that you use when you're doing your research. So we're going to play a game, Price is Right style, where our panelists are going to try and guess how much a tool Karl uses in his research costs. And if you are watching at home, play along, put your guesses in the chat. We call this game Grant Me That. So how much does Karl have to ask for in his grant applications if he wants to get one of these tools? And remember, panelists, you're trying to get as close as you can to the right amount without going over. So here's our first piece of equipment. What do you think this costs? This is a fancy treadmill that Karl uses in his lab. You can see it's all rigged up. They have someone running. They have someone else observing. How much do you think that treadmill costs? Let's go down the line. What do you think? What do you think here? Joe?
Yeah, okay. I'm going to go ahead and say $2K.
$2,000. Okay. Naomi, what do you think for this?
I'm saying $200,000.
Come on.
$200,000.
Honey, this is science.
Mm-hmm.
We don't know science.
That's true.
Yeah.
That's so true.
I'm thinking you got to compete with the video game community and EA Sports and whatnot, and that's going to drive the price up. So I'm going to split the difference because I do watch The Price is Right. Shout out to Drew Carey if you're watching. $75,000.
$75,000. Okay, let's find out. And also, thank you so much. Drew Carey is watching right now. He's always on this. He's constantly watching our Zoom-based live streams. He loves this show. Let's find out, how much does this treadmill cost? $100,000, which means that Drew Carey is coming on down to give you your prize. Rob, you were correct.
Wow.
$100,000 though, that is an enormous amount of money for a treadmill. That is more than the most expensive Peloton costs. So why does the treadmill cost that much, Karl?
I liked Naomi's reasoning on this one. So that treadmill has special sensors integrated into it where we can very precisely measure the forces under people's feet as they walk or run. And it records those at 2,000 times per second and allows us to better understand how people move. And whenever we give them different types of enabling technologies like prosthetic limbs or exoskeletons, whether we're having the intended effect and benefit to them.
Is there like one company that makes the $100,000 treadmill?
There are a handful that make them.
I have a question though. How long, because obviously it's not like a treadmill that you have at home, which you pretty much use to hold clothes, if you're me. So like this is getting a lot of workout. How long will this last? Can you have it like for the duration, or do you need to get a new one every couple of years?
Oh, great question.
We've had this one for 8 years. It's still working well. You do need to calibrate it from time to time and take care of it. So it's a piece of, electromechanical machinery. So you've got to take care of it, but they last quite a while.
Okay. Well, that's good. All right.
Why is there nothing to hold on to? Is that, is it invisible or like?
Yeah, there's none of the side handles there.
Yeah, the side handles, because when I'm running the treadmill, eventually I'm gonna need those.
Yeah, this one will just fire you off the back if you run out of steam. So we do have installable handrails that we use for some experiments, and we also have an overhead harness. So if we have individuals that might be likely to fall or get winded and need something to hold on to, we will anchor them to make sure they don't hit the ground.
Huh.
Yeah, I need that. I need that for my home. Absolutely.
Yeah, that's why you get that. Have you ever run on the? Someone from the chat asked this. This is a great question. Have you ever run on the treadmill, and was it better than the gym?
Yeah, I've run on the treadmill before, and of course it's better. I get all sorts of scientific biomechanical data from it. It's great.
Okay, well that's the first one, $100,000 treadmill. Let's look at another piece of real equipment that Karl uses in his lab. This is our second tool right here. This is a real tool that Karl uses. How much do you think that costs?
Wait, what is it?
Is it a Fitbit?
Without knowing what that is, he uses that as a scale. That's a scale.
Scale.
Okay.
Okay. So scale like a Bed Bath Beyond, it's probably gonna be like $18. So I'm gonna go ahead and say times that by 60. What is that? I'll go to
In the chat, type in what you think 60 times 10 is.
Let's go ahead and say $700.
Okay. Joe says 700. Naomi?
Okay, I'm actually gonna come in. I'm gonna come in at $650.
650 or $6.50?
650. I've told you we don't know science.
Okay.
Just
yeah.
assume it's expensive.
That's true.
Okay.
Okay. And Rob, what is Drew Carey telling you in this moment?
By this strap, I don't think this is expensive. This looks like an Amazon picture, so I'm gonna go with $35.
$35.
Mhm.
Well, let's find out what it actually costs. $20. Everyone went over. You were correct. This is an Amazon picture, though.
Dang.
Rob
Yep,
is
this
so good at this.
He is
This
so
is
good at
just-
this.
a regular old luggage scale, and you used
What?
it, Karl.
Oh yeah, absolutely. And 20 was generous. I think the last one of these I bought was about $7 or $8, and it was it was probably off Amazon or some normal site. Not everything in science has to be expensive. We do engineering development work, and sometimes we just need a way to be able to pull on something and get a rough estimate of how much force is being applied, and that helps us understand is a component likely to break. And my lights just dropped out, but
Okay, I'm
whole
sorry.
idea-
Your lights aren't working,
We can
engineer.
still see you.
We can see you, but I'm also like, okay, I need to call Vanderbilt. They're not giving you what you need.
Yeah.
Oh, we're back.
There we go.
Okay.
Okay.
Yep. So just a
Guy.
cheap luggage scale.
Oh, wait, Karl, do you have those lights that go out when they think no one's there?
Yeah, and I'm pretty sure after about 6 o'clock, they must turn that dial down to if you haven't moved in 10 minutes, then the lights are going to
Really demoralizing, I find.
Yeah.
You know what they think that.
This is
Well,
my
the
sign that I
lights-
should have gone home.
The lights say like you have no physical activity. For all intents and purposes, you are dead. That when they go out, I hate that. Okay, so one of your tools is $100,000. One is less than 20, maybe even less than 10. Let's look at the third one. Last one. This is the last one. Okay, these are reflective markers that Karl uses with a special camera to keep track of motion. How much do you think that these reflective markers cost?
Per,
No, let's say total.
for like, what's that, 20 of them?
Yeah, a little tray of them.
Okay, tray of little markers. I think this is also an Amazon purchase. I'm gonna go ahead and say this is, no, I'm gonna go ahead and say $1 million.
Okay. All right. Well, Naomi.
Okay, a tray of reflective markers. I've never seen those before in the world. Okay, so let's assume specialized. Okay, they are petite, however. I'm gonna say $85.
Okay. And Rob, so far you've been a real master of purchasing scientific
Okay.
equipment.
They got little like adhesives on them, so I'm imagining you just get one use out of them. So I'm gonna think you need them a lot. I'm gonna go $100.
Okay. Let's find out how much these cost. These were the cheapest ones yet. These are $10
for a whole tray.
What?
Karl,
For a whole tray?
Carl, convince them. You told us this information. What do you think? Is that true?
Yeah, a 10 was closer to the cost of one of them, so I think around $100 might be closer to the right answer.
Okay, you know what? That's
Rob and
fine.
Naomi
We'll
were
go for it.
close.
$100.
Yeah. So these are
Okay.
somewhat specialized. We have cameras set up around the room that are infrared, and we put these little reflective dots all over people's bodies. It's the same thing they use in the video game industry and the movie industry when they created the Hulk or Gollum from Lord of the Rings or Avatar. And instead of overlaying cool animations, we overlay a lot of math and physics to understand how people move.
Amazing. Well, Rob, you have a real future as a contestant on The Price is Right. That's one thing we've definitely learned in addition to Karl's research. And so, Karl, we've talked a little bit now about how you do your research, the tools that you use. Let's get a little bit deeper into the point of your research, what you're actually building with that. So we're going to get into that in a game called There's a Suit for That. So here's how this game works. Karl's job is all about figuring out ways to help improve and expand our physical abilities. And so panelists, I would like for each of you to take a second and think about a scenario in your life where you wish you had some sort of exosuit or prosthetic that could help you. And Karl will then tell us if such a thing already exists or what it would take to develop it. So I will start. For myself, one thing that I really like to do is I often like to make a little pasta as a treat. But sometimes the top of the sauce jar, too hard for me to get open, and I feel embarrassed. I'm humiliated that I can't open the sauce jar because my wrist strength is not strong enough. I would love if there was some sort of prosthetic or like an exosuit, pasta sauce based wrist strength enhancer. Is that something that you've already made or something that you could make, Karl?
I love the passion for pasta sauce and the specificity here.
Thank you.
To be honest, I think that what you're looking for is just called a jar opener. And I think you can get for about $10 on Etsy. So I think you should set your human augmentation superpower goals and vision a little bit higher.
It's just called a jar opener? What is it?
It's rubber. It's really good.
Okay, well, this is I'm not faking this. This is news to me, and this is life changing. So that's great. I hope that each of you gets a response in response to your scenario that is as fulfilling as that. Okay, Rob, let's start with you. What's a scenario in which you wish you had some sort of biomechanical assistance, and then Karl will tell us if it already exists, and you could buy for $7 on Etsy.
Okay, you know this little space right here in your nail that starts to peel. I pick at it too much and then it starts to bleed. It's very embarrassing. Sometimes I gotta shake people's hands. So if there was something that could put some force field right there so that I'm not picking the nail sides, or or a glove that looks like my hand or something like that, then I'd appreciate that.
So Karl, does that already exist? What would it take for you to develop that if it doesn't?
To develop that?
Karl, bless your heart.
It sounds like he should wear some gloves is maybe the
Can you make the gloves look like his hand?
Yeah, can the gloves look like my hand so that people don't be like, wait, why do you have on gloves? Only superstars wear gloves. I'm not a superstar yet.
I think some skin tone gloves might be
okay.
That's going to be a good stocking stuffer for you this upcoming year.
Truly, no punchline will ever be funnier than the expression on your face as you thought about developing that, Karl. That is so good. Oh, okay, Naomi, give us a scenario where you'd like a biometric assistance or of some kind.
Okay, so I am always afraid of zombie apocalypses and hurricanes and all that kind of stuff because I live in LA, which is not habitable. But I have 2 cats and a dog, but I have 2 hands. And I am is there a way, I'm in an emergency situation. I got to grab all my children, you know what I mean? And hold them close and get out of there. Is that possible? Can we make it possible?
Yeah, that's a great one. People are working on this. So they're called supernumerary or extranumerary arms. People are working on additional appendages, additional limbs that you would be able to attach to your body.
Yes.
And the real challenge is figuring out how to control them naturally. So you can easily control your hands, you can manipulate objects, but how do you use your brain power or your muscle signals or something else to control these extra limbs? So The hardware exists, and there are people trying to explore how to develop controllers that will allow your body or your central nervous system to interface with these additional limbs.
Okay, great. Now, do you think that would be the same price as the scale, as the luggage scale? Do you know what I mean? Because I don't, if it costs like real money, I may not have access.
Yeah, I'd save up. I think it's going to come in a little north of $20.
Okay, well, actually, that is a very real question. And someone actually brought this up in the chat too, which is, as you're building these exosuits that are kind of amazing and give people all this power, how do you make sure that they are not just accessible to like billionaire Batman supervillains and Spider-Man supervillains? How do regular people get access to them too?
Yeah, we want to bring our groceries with one trip.
Yeah. Absolutely. Yeah, that's one of the big things that's changed. When I started in this field of exoskeletons and wearable technologies, it was all some combination of science fiction or just laboratory research. And in my adult lifetime, in the last 15 years, these technologies have actually moved outside the laboratory. There's medical exoskeletons for people with disabilities. There are some consumer exoskeletons for people that want some extra assistance when they're skiing. There's occupational or industrial exoskeletons. And the prices have been dropping. There's a lot of these technologies that are more like wearable tools and becoming more affordable than they are like super suits. And that's been one of the big changes is it's less Iron Man and much more practical wearable tools. And for devices that are intended for a specific audience, you have to take into account what can they afford? How do you get these devices to people who can benefit?
Okay, last one, Joe. What's a scenario where you would love to have some sort of biomechanical assistance?
So I went to a musical the other day, and then during the intermission, it was a really long show. And during the intermission, the bathroom line was 50 people deep. Okay, so I'm just wondering if there's like something that can squeeze out bathroom stuff out of people quicker.
So this is a very interesting question.
Scientists throughout the ages have been trying to figure out, can we squeeze out bathroom stuff quicker?
I definitely thought with the music that this was going a different direction and was all lined up for musical exosuits that help musicians play, but this took a complete left turn. What's interesting is there are some people that are working on implantable devices that would fit around organs, think like your heart, that would help pump your heart if you were having heart difficulties. And I suppose, you know, you're breaking new ground here, but maybe if you take that kind of cardiac assist device in pumping your heart, but you were to apply it to the bladder, you could actually expedite that process. Now, how you would convince people to get that installed inside of them is another issue, but you know, you started down this line of research, so Joe, I think you should run with it.
Okay.
Okay, sounds good,
Karl, do you ever regularly work with kindergartners? Because I do feel like the level of question we are giving you are of small children, and you are so positive and strengths-based that I think you need to go out to the youth of America. Because, bless.
Thanks for saying that. My son is in kindergarten, so I'm well.
Yes, very clear. You're clearly dealing with this on a daily basis.
Show him the Jetsons.
Karl, one thing that people are asking in the chat, which I think is a fair question too, is, you know, so many of the people who use these things in media, right? When we see like in movies or on TV, so many people who are using exosuits or biomechanics, they're villains. They're not good. They're kind of trying to destroy the world, and they have built themselves some sort of suit, with the exception of Iron Man, who was a hero. But how do you feel about that? Does that feel insulting to your profession that so much of it is used for villainy?
Yeah, certainly on the big screen, there is a lot of developing these kind of super suits or exoskeletons for nefarious purposes. I think it's fine as entertainment. I think it's just interesting that a lot of people get their primary worldview of these exoskeletal technologies from the big screen and maybe don't realize just how practical and commonplace these types of technologies are already starting to become. So it's kind of fun for me to see, you know, this is the vision that many people experience, but my day in, day out is seeing people who are maybe individuals missing limbs who wear prostheses, people with disabilities who are benefiting from getting additional rehabilitation from exoskeletal devices, or just people that work really hard, that are overburdened, that are at high rates of injury, musculoskeletal injuries, and are benefiting by having more energy at the end of the day so they can go and do the things that they enjoy. So it's becoming much more practical, and I think it's interesting to see both sides.
So we're going to actually take a look at some of those specific suits that you've worked on in a couple of minutes. But first, let's take a look at what Karl is like outside of the lab and what he's like as a person. So we're going to play a game of 2 truths and a lie. Okay, so here are the 2 truths and a lie. You have to guess which is which. 1, Karl once sent chia seeds into space. 2, Karl holds high school and college jumping records in track and field. Or 3, Karl hiked the entire 2,190-mile Appalachian Trail. So panelists, I'm gonna ask you to discuss these with each other and come up with what you think is the lie. Also,
I know.
If you're at home, please, we wanna hear you too. Naomi, what do you think? Talk amongst yourselves. What do you all think is the lie here?
Guys, here's my theory though, because we already saw this like montage, okay? So we saw, it wasn't him jumping. They showed some other black person jumping, and I said, that's not Karl. You know what I'm saying? However, we did see him like, you know, holding plaques and stuff and in sporting outfits.
We did.
So I think he's sporty. He's active.
Yeah, I mean, and if you're going with that logic, I mean, chia seeds into space does not seem that active to me. You know what I mean? Why isn't Karl going to space?
Yeah.
If it is, you know, I bet Karl went to space, didn't send the chia, sent himself. Yep.
Right. Also, what does space have to do with the biomedical engineering? Sure, weightlessness, but like also, that's a little off. That's a little off brand a little bit. What do you think, Rob?
I'm thinking, you know, chia seeds makes me think of chia pets.
Sure.
Which have no place in space right now.
Sure.
You know, we got a lot of priorities that we got to get to before we start bringing our chia pets to space.
Right.
We haven't talked about this Appalachian Trail.
Yeah, that is a toss-up. That could be a toss-up because it is very long. I don't know.
And Karl has a kindergartner.
Yeah. So do you think, you're saying he doesn't have the time? Like, when could he have done it? But Karl did this when he was like, he did this like between like one of his graduate degrees. Do you know what I mean? I imagine like part of Karl like resetting is like, let me go into nature before I get another degree.
Eat, pray, love.
Exactly.
He said in the thing that he liked to push his body to the limit.
Yes, of course. He'd eat the chia seed. Maybe he sent the chia seed into him.
Okay, so I think we've had some good discussion. Let's hear it. So Joe, you think that the lie is number 1 because he didn't send them into space, he sent them into himself, into the space inside of himself. Is that correct?
Yes.
Naomi, which one do you think is the lie?
Number 1. It's not about space. It's about the concrete movement and the tons of force across a space.
There you go. It's not chia seeds because he was spending his time studying a concrete booth instead. And Rob, what do you think?
I want to be different just for the strategy purposes, but I really do think it's number 1.
Okay, universally thought that it is not chia seeds in space. Let's find out what was the real lie. The lie is Karl did not hike the Appalachian Trail. In fact, Karl suggested this as a lie and said, I could do nowhere near this thing. If I did it, I would need some serious exosuit assistance. Right, Karl? That's what you said about this?
Sounds right.
And Karl, you don't like hiking at all.
I enjoy much shorter hikes. That is far too long.
No.
Have you ever sent chia seeds into yourself?
Not intentionally.
Okay. But you did send them into space.
Why are they in space, Karl? You make
outer space?
Why are they in space?
Yeah, good question. Outer space is that's I agree with Rob there.
Yeah, I love that it was described as off-brand. This happened back when I was in middle school, in junior high. We had a really great science teacher who was connected to NASA, and they had a little extra payload space going up on one of the final John Glenn missions. And when you ask some middle schoolers what they want to send up into space, it was chia pet seeds and sea monkeys.
Wow.
Amazing.
So you're a science industry plant. That's what's going on. You were plugged into NASA early,
right?
You were tied in from the start, but you also hold records in track and field.
Yeah, I come from a family that did a lot of track and field. My brothers were hurdlers. I was a long and triple jumper. And to my knowledge, I think I still hold high school and college records where I.
Okay, wow. Okay, wow. They better be inviting you to speak at graduation. Between the track and field and the exosuits, you're the best.
Have you ever given a talk at your high school? Have you spoken at graduation?
No.
Wow. Okay.
Wow.
Drew Carey is the principal of that high school. We got to get you. You got to be on both.
You got to bust in there in the suit. Yes. You got to wear the suit and then get on stage and just give the speech unplanned.
That's who's going to stop you while you wear an exosuit. Okay, I also want to say that as I was preparing for this segment, I was trying to find more facts out about Karl. And I got to talk to Karl's wife, Tiffany, and she gave me so many great facts about Karl, so much incredible background information that we couldn't even fit into this segment. But she also had a fantastic answer that I want to share here, which is I asked her the question. I said, Karl works on making robotics and technological assistance for other people. But if Karl was going to get some sort of assistance for himself, what type of assistance do you think Karl most needs? And here's what Tiffany said.
I think if someone could drive for him, I think that would be the best solution because he tends to think while he drives. And so if we could I know they're working on it, but if we could just speed that up and have him have a car that drives for itself so that he can think and still maintain the proper speed, then I think that'd be the way to go.
And I asked her, I was like, does that mean that he doesn't maintain the proper speed? Like he's going too fast or too slow? And she was like, absolutely too slow. Way, way, way too slow. Which I think is a better way to go. You got to go one. I'm glad you're going like 15 miles per hour while you're thinking.
Yeah, if you ever get caught behind somebody on a highway and they're going like 45 miles an hour, often people assume it's some really old person that shouldn't be driving, but sometimes you're just behind a scientist who's deep in thought.
Yeah.
I imagine you beautiful minding your like windshield.
I also asked Tiffany if you ever try and get her to wear exosuits. And Karl, she said, yes, 100% of the time you're trying to get her to wear exosuits. She also said, this is the real secret to peace in your marriage. Let's play this clip.
Tries to. Yes, he tries to. I think basically the way to get Karl to do anything is if you tell him he can wear the exosuit, then he's all for it.
That's incredible. What an incredible marriage hack right there. Tell Karl he can wear the exosuit. He'll do whatever chore you want him to do as long as he's allowed to wear an exosuit while he does it.
Yeah, she's kind of abusing that, but she's got the right move. She'll mention like, oh, that toilet in there needs some kind of repair to it. It's going to involve a lot of bending and lifting. And I'm like, I've got this one. grab the suit. I'm halfway done with the job. And I'm like, wait a minute.
You're also getting some serious respect from the audience. Someone said, I love triple jumping. My opinion of Karl has gone way up. I love that after all of your scientific accomplishments, the thing that made them impressed was your triple jump.
Yes.
Someone also said that for someone who is claiming to be young with the Jetsons, you're really dating yourself with chia pets and sea monkeys. So you're coming through there. Here's a question that someone asked about the prosthetics is if you get a sophisticated robotic hand, how long does it take for your brain to get trained to work with your prosthetic hand?
Oh, yeah, great question. I actually, just a couple of weeks ago, I had a guy happened to be visiting Nashville, and he has two double amputations. So he's missing both of his arms, and he has two really sophisticated robotic hands. And we had a really great discussion with him about this. The short answer is it takes a while. There are some different ways to integrate prosthetics into your body. There's a new technique called osseointegration where they actually physically connect the prosthesis to your bone. They hollow out the bone and drill the prosthesis in. And then there's some different ways to take your muscle activity. So each time you contract your muscles, they generate electricity. You can pick up that electricity with a bunch of different sensors, and then you can run those through a machine learning algorithm in order to teach a person how to make different hand gestures with their robotic hand. But it does take a while. It takes months to develop for the device to learn the person and for the person to learn the device.
I have a question, Chris. Can I ask it?
Of course, please, at any
in the
time.
chat.
At any
So with
time.
something like that, though, is that what you would do, or like I guess sort of what's the relationship between physical therapy, with like a PT versus the science of it? Because it sounds like it's really like I need to call up a Karl to handle this. I wouldn't call up my doctor.
No, you should absolutely call your doctor. If you lose an arm, please go to the hospital.
Oh, I mean, once you got your prosthetic.
Do not knock on my door. No. So there is the current state of clinical care. If you lose an arm, if you lose a leg, if you're injured, you should see an appropriately qualified medical professional.
Yes.
And what our job is as biomedical engineers, as assistive device developers, is to look at what is the current state of technology. What are the limitations, like these lights? What are the limitations that people have in terms of what they can currently do, activities of daily living, or just being able to go out and participate in the things they enjoy? And we try to envision, hey, where could this technology be 5 years, 10 years, 20 years down the line? And we focus our attention on developing the science and the technology to create the next generation of these technologies. So I cannot help you at all right now if something happens to you, but the hope is we're building that foundation so that 10 years from now, the people who do need these devices have better, more enabling technologies than we currently have.
Well, Karl, can I ask a question? How do you make sure that the body doesn't reject, wouldn't the body be like, this is a foreign object? I need to get rid of it? Like how a body can push a stapler, or not a stapler, a splinter out,
Yeah, no, that's a great question. And biocompatibility is a big challenge. This concept I described as osseointegration, where you actually take the prosthesis and you embed it directly into a person's bone, has been studied for decades. And it took them a very long time to develop both the hardware, the chemical coatings that they have to put onto it, the procedure of how do you actually install it into the bone, the continuous care. So you have to keep cleaning the site because you literally have a prosthetic limb sticking out from inside your body. So it took years to develop, and that's the power of science and different experts coming together, from biocompatibility to hardware to medical science in order to enable this capability.
Well,
Sorry, did someone else have a question? No, Karl, one of the questions that someone's asking that I'm also really curious about is, what's the wildest suit or prosthetic or robotic assistance that you've imagined?
The wildest suit,
or just what's the wildest kind of biomechanical assistance that you've imagined or dreamed up yet?
A lot of it doesn't seem so wild anymore. I don't know. Years ago, I thought it all seemed almost unfathomable. And I think some of the things that seem completely crazy, but actually work are, you can, for instance, if you were to lose your arm, there are procedures where they can take the nerves that used to run out to your hand. They can reimplant those nerves on other muscles in your chest. So when you think in your brain, wiggle your finger, it actually contracts a muscle in your chest, which generates a signal, and then they can measure that signal and use it to control a prosthetic hand. Wow. So it's called targeted nerve reinnervation. And there's cool procedures like that where you can actually rewire the nerves of your body to control technology. And it works. And it's become one of the ways that they provide capabilities and control of prosthetic limbs back to people who have lost their limbs.
Now, does my insurance cover that? Because it does feel like I might need some better coverage if I wanted to get that kind of hookup.
I do not recall that.
Uh-huh.
Yeah, see, that feels like a legal
Blue Cross ain't
right
gonna get down with that. Blue Cross ain't hooking me up.
Yeah.
Wait,
yeah,
but I mean, does anybody really think I'm gonna move my finger? Do you know what I mean?
Oh, you mean, is it a conscious thought?
Oh,
yeah, like I was just thinking right now, I was like, go move your finger, but then I didn't do it.
Joe.
You can't move your fingers, though, right?
Yeah, I can, but like, if I was like, I didn't think like move the arm, move your arm, move your arm, like it. Do you know what I mean?
Okay, so it happens. It's so natural to you. It happens at a subconscious level. But if you were missing your arm, you would be able to think, hey, move my finger, or do whatever you typically would do to move your finger. And what's cool is now, instead of the signal racing down your spinal cord and going out and controlling a muscle in your finger, it can control a different muscle, which is read by a sensor, which goes to a processor, which is connected to a robotic limb, and you can now control that robotic limb.
So we're going to actually look at some of these, some of the suits that you've made in this next segment. But someone's asking a question that ties, is a perfect segue here, which is how do you keep exosuits lightweight enough that people can benefit from them despite the weaknesses of making something lighter weight?
So the idea of, can you make something lightweight but still assistive is, I think the key is just to make sure that's a design requirement on the front end. If that's something that's important to the end user, then you start from the very beginning saying, hey, we have to create something that's lightweight. And I'm kind of picking my words carefully because I think some of the images you're going to show coming up might be related to this. But
okay, so as we get into this, then we can
I can maybe expand a little bit.
Okay, so let's get into this next segment. This is called Suit Up. Okay, so panelists, in this game, I'm going to show you a photo of an exosuit or an assistive device, and then you try and guess what it does. So let's take a look at this first. Exosuit. Okay, this is Karl. This is Karl and some of his colleagues in the lab, and this is a device that they have built themselves and created. What does that do? What is the purpose of this device, do you think, based on looking at it? Who's it for? What does it let them do?
Clearly, it's to help people who can't dance learn how to moonwalk.
Yeah, certainly seems right to me. Naomi, Joe, any attempts here? And remember, the show is called Wrong Answers Only.
Oh, wrong answers only.
I mean, you can say whatever you want, but just so you know how the points are going to work.
Oh, I think it's to get your legs moving faster than they've ever moved, right? So it's like kind of getting them to go faster based on what you can do. It says there's one guy with like a little knob that's like faster.
That's what Karl's doing when he's squatting down there. He's turning up the speed on the leg.
This to me is muscle. It's about contracting your muscles. Remember that thing women used to do in the 50s where they would just have that belt just whir around their stomach? That's what this is doing for the core and the glutes.
I remember seeing the commercials for that thing where you lie on the couch and it just contracts your abs for you and being like, why wouldn't everyone just do that? That's a perfect solution right there. Okay, Karl, what does this actually do? What do you think?
Okay, so this is a robotic lower limb exoskeleton. It was developed by a colleague of mine here at Vanderbilt named Michael Goldfarb, who's one of the pioneers in wearable robotics. And it is a device for people who are paralyzed. So imagine you're paralyzed from the waist down. Normally you would be wheelchair bound, but this actually allows those individuals using robotic motors to stand up and to walk. It's an FDA approved product now. It was licensed and commercialized. So if you're an individual who's paralyzed, you can actually get these to allow you to ambulate, to walk in your home, or in some cases they're used for rehabilitation, meaning they help give people practice moving their legs. In some cases, people have a partial paralysis, and this can help them to regain some of their neuromotor capabilities, some of their abilities to walk and move.
Do you charge it?
In some ways, all three were right? This is getting you closer to doing a moonwalk. This is contracting muscles and moving your legs faster than they can previously move.
I think you got 3 winners there.
There you go. Okay. Let's take a look at the next exosuit. What do you think this suit is used for?
Kind of like a squatty potty for more comfortable poos.
Okay, yep. Easy way to get in the right position to eliminate. Or as Joe would say, to squeeze the bathroom stuff out of your body.
Yep, for squeezing the bathroom stuff out of your body.
Dang. I'll go ahead and say it gives women a bun.
Creates a bun in women's hair. Yep.
No man buns though. This is a duck machine. So, something gets thrown in the air, somebody's like, duck. This helps pull you down way faster.
Way faster. Avoid those things coming at your head. That's a very useful device. Karl, what is this one?
Okay, so this is a back assist exosuit. So this is designed for people who work in physically demanding jobs that do a lot of bending and lifting. Think somebody who works in a warehouse, or somebody that does a lot of bending and lifting on an assembly line of a manufacturing plant, or people in construction. And we basically developed a 3-pound suit that can take about 75 to 100 pounds of strain off your back each time you bend or lift. So this is a good example of, it doesn't have to be a heavy, bulky, rigid device. This device doesn't have any motors. It doesn't have any batteries. It uses elastic elements that basically act like artificial back muscles. And that's how we were able to create a very light device that provides back relief to people who need it.
And this is from the company HeroWare that you work as the chief scientific officer for.
That's right. Yep. This was a device we initially did biomechanical research on at Vanderbilt, developed some early prototypes, and realized there was an opportunity to help people who were at high risk for back strain and back pain. And then we spun out this company called HeroWare, which is based here in Nashville, and that now has commercialized this product and again serves industries like manufacturing and logistics and construction.
What do you hear from people when they try this? Because I imagine, right, there's a lot of construction workers who've been doing this for years. They've had strain on their backs. When they try this for the first time, are they like shocked, or is it more of a subtle thing where it kind of like prevents injury, but it doesn't feel so different in the day?
Yeah, I think people are shocked because they see something that just weighs a few pounds. It doesn't have motors, and they kind of assume, hey, that can't provide that much relief. And then we usually have them do some lifting without the device and then put the device on, and people immediately feel the relief in their back. And then the most impactful feedback is people that are wearing it day in and day out. So there's workers now that use it and say, hey, I can go home and have more energy to play with my kids at the end of the day, or I come back the next day more refreshed, or I have less back pain. I used to always have back pain doing this, and now I'm not in as much pain. So those are the real rewarding things. And more recently, we've been working with the U.S. Army to develop some similar suits for soldiers who do a lot of heavy bending and lifting, and that's been really rewarding as well. They work really hard.
Okay, let's look at this last exosuit. This one is not Karl's, but it is an exosuit. What do you think this one is used for? Okay, obviously the person in this suit does not look super happy. Doesn't look like a thrilled man in that suit. But what do you think this is an exosuit used for?
He's going underwater. This is to prevent the bends.
Okay.
That's what he's doing. Something's going to keep him up, and he's not going to buckle under the tons of water pressure.
Naomi, that's Naomi's guess. What do you think, Robert or Joe? What do you think?
Hublot is like a diver's watch, I think, company, I think. So, but like people have been diving in the ocean for many years. So I'm going to say this is for lava diving. Hot lava diving.
Okay, wow.
Mm-hmm.
It is a very thick suit, very thick. Joe, what do you think?
I'll go ahead and just say like a desert. I'm gonna go ahead and say desert.
Okay. That I feel like that's not really a purpose. It's more a location that you just named.
Okay,
what in the desert?
I was trying to strategize. Kind of everybody said something different, so I thought maybe that would be a good way to go.
You have to say, what are they using for in the desert? You can't just say the word desert.
Okay, well, Karl, I'd love to brainstorm with you, but yeah, pretty much kind of going through what else can you do there? That's it.
Okay.
Yeah.
All right, so we got it's used for diving in the water, it's used for diving in lava, or it's used for kind of going through the desert and a request for brainstorming with Karl. And the answer is this one is for deep sea diving. This is to get you way deeper than a scuba suit could ever get you. So Naomi was exactly right. Yeah, that's a deep sea diving suit. And Rob, incredible that you knew the brand of diving watch yet again. This is a shocking display of you should be on The Price is Right. We have seen your knowledge of all sorts of products here.
I learned that from Jay-Z. Once Jay-Z gets excited about a product, he'll tell you all about it. So yeah.
Okay. I want to ask you a couple of moral questions, ethical questions, Karl, since a lot of people are bringing them up in the chat. The first one is someone saying, I'm watching the NBA game right now as well, simultaneously watching that and this show. And what is your take on using prosthetics in sports and concerns around them maybe providing inappropriate benefits to some athletes? Or do you think that that's the future of sports?
So in terms of wearable technologies in sports, I think there are some really cool opportunities to use them to help people rehabilitate after injuries. or in order to monitor just how much wear and tear they're putting on their body, so you can help inform when they should be training more, when they should be resting more. In terms of whether certain types of technology should be allowed in-game during competition, I think those are more rules that have to be decided at a kind of a sport level, whatever the committee or body is that oversees that sport.
Okay, we also got a question. In the film I Know Who Killed Me, Lindsay Lohan had a big problem because she forgot to charge her prosthetic leg. Do real robotic limbs need to be charged?
Real robotic limbs do need to be charged. So that's one of the challenges with any type of wearable robotic device that is powered, is you need to make sure that you're able to either charge it or be close to a power source where you can swap out a battery if it's needed. It's also one of the reasons that even though people think of exoskeletons as wearable robotic devices, a lot of the devices that are getting traction now are actually unpowered. They use elastic elements and springs, and they don't have batteries and motors, and that allows them to not need to be recharged. So not all wearable technologies need to be recharged, but the ones that do have motors and batteries absolutely do.
So once again, Lindsay Lohan scientifically accurate in her films. So what a relief. Okay, other questions? What other people want to ask? Any of you three, Rob, Naomi, Joe, any other questions for Karl here before we move on?
No, I was curious about the whole charging thing. Cause yeah, okay, remember the first one we saw that you developed with your colleagues? Like, I guess for instance, how long do you run on a single charge? You know, is this meant to be an all-day thing? You know, the one that assists people who are unable to walk, helping them stand and walk? Is that just a brief moment? How long does it last?
Yeah, I can't remember that one specifically, but for those types of use cases where you have somebody who's paralyzed and needs to get up and move, you generally want a device that can at least last on the order of hours. You know, these aren't individuals that are going to be going 24/7, but there are other applications where you do need devices that can last much longer. So it's usually about matching whatever your use case is with what's the minimum amount of battery life, or how do I create some, you know, quick swappable battery that will allow somebody to keep going. And if you do run out of battery, making sure that it fails in a graceful fashion, right? That it kind of enters a mode that is safe to use. That's another key to developing these devices in a way that is practical and safe.
Is it?
Okay. No, go for it, Rob, please.
Is there any like thought to maybe, like, you know how at the grocery store they have those carts for you know, like people, they'll walk in, but then they'll get on the motorized cart in the grocery store. Is there any thought to like using robotics or an exosuit for people like that, you know, they can walk, but they rather scoot?
So just to give people another option for kind of local mobility. I think so. It's interesting to see how creative people are getting with these kind of devices. I just think of exoskeletons as wearable tools. And so if there's a problem where somebody's unable to walk in a store or over a short distance, you know, how do we create something that's enabling to them, that helps them participate in society in the way they typically would? And there probably are opportunities, like you said, in the same way that things like motorized scooters popped up to fill certain niche of mobility. There's probably in the future going to be opportunities to, I don't know, grab an exoskeleton for different use cases in your daily life.
Well, we're coming to the end of the show. We're almost out of time. And so before we go, since we've been looking at some photos and some videos of your work, I just want to show this other video that you sent, Karl, because it really makes me laugh. This is a video of regular work in your lab. This is how you kind of study the biomechanics of gait and what people look like as they're walking, and specifically as they're tripping. This is, Karl sent me a video that shows one way his team studies people's reflexes and balances. It's by intentionally having a robot trip someone while they film them on a treadmill. So let's watch that. Let's watch that video right now. For some reason, that really does it for me. That man wearing sunglasses and just being forced to, at some point, he's going to fall over on his head. Do you ever really like lay people out? I mean, that man was obviously just a stumble.
Yeah, that was my boss's boss. So that was just kind of a gentle one to give him a sense of what we were working on. I still have my job, thankfully. But yeah, we actually do try to trip people. This is a case where we have the safety harness that's connected to the ceiling to make sure people don't fall. But the key is we're really trying to understand how people recover their balance. And then what we do is we build those human-like reflexes into robotic prosthetic limbs to help people with amputation who are more likely to fall down and get hurt.
Well, thank you so much, Karl. I really, really appreciate you being here and talking to us about your work. We're at the end of our time, so I'm going to check in on the score. It looks like Rob had the most points and Joe had the least. So Joe won by having the most wrong answers. Congratulations, it was wrong answers only. Or if you want to look at it the other way, Rob lost by winning, and Naomi, you were close second, so you stayed right in the safe spot between the two.
Yeah.
Before we go, Karl, I think you've given us so many reasons why people should care about this research and why it's important. But what do you hope audience members will take away from tonight's show?
So I hope people take away that biomechanical science and assistive technology provide ways to improve health and well-being and to reduce disabilities in society, so that we can all live more and hurt less. And I think those are things that we all care about.
Beautiful. Well, Karl, thank you so much for that and for everything that you've shared in the show and for the research that you do. And now, panelists, you've heard what Karl hopes that you take away from tonight's show, but what will you actually be taking away? Rob, what are you going to take away from tonight's show?
I'm taking away that, lab equipment isn't as expensive as you think, and it's time to start building a lab.
Okay, that's great. The future of science is now. Rob Hayes, thank you.
Mm-hmm.
Naomi, what are you going to take away?
That I need to look into my medical coverage, and that should something go down, can I get the top of the line? I'm looking for this top of the line Karl Zelik joint. Okay.
Yes,
that's what I want to check.
Fully support that. We can get you a prescription straight from Dr. Zelik himself. So we will definitely be supporting you as you're on the phone with your insurance company. And Joe, what will you be taking away from tonight's show?
Just kind of like what I'm just really reeling on, like what kind of suit you could use to fix the toilet, because you kind of dropped that and then left it there. So that's what I'll be thinking about that for a while.
That's the mystery. That's the mystery. Maybe we will even put that in and ask people for their feedback in the post-show emails. What kind of suit would you use to help fix the toilet? Thank you so much to all three of you for playing. Thank you so much, Karl, for being here. What a fantastic group of panelists and an incredible comedic group and an incredible scientific guest. So if you are in the audience, you are going to get an email after this show with bonus information from our expert and links to get deeper into Karl's work and research. You can find out all about what he does and his companies, as well as amazing jokes and videos and comedy from our panelists. You're going to see links to follow all of them and to make sure that you stay up to date with all of them as well. And of course, we talked about it before, you're also going to get that trivia question, which could get your name on the scroll of glory if you answer it correctly. And we would also love to get feedback from you about the show. We're always trying to make it better. That is it for tonight, but we are back in June with a special show for World Ocean Day. And you can sign up for reminders for that right now at the website that you are currently on, labx.org/WAO. In the meantime, though, thank you so much to tonight's expert, Dr. Karl Zelik. Thank you to our panelists, Joe Firestone, Naomi Ekperigan, and Rob Hayes. Thanks as well to everyone at the National Academy of Sciences and LabX, and our back-end folks, Amechi, Jesse, Amir, Dempsey, Mario, everyone on the tech team. I am your host, Chris Duffy, and this has been Wrong Answers Only. Find out more about this show and future episodes online at labx.org/WAO. Have a great night. Stay safe. Bye. Bye, everyone.